In this video, I want to have a look at correlation. So correlation is something that we talk about when we're looking at bivariate data, which is data that's relating two different variables. So the reason we look at correlation is that it helps us to determine whether there's a linear relationship between our two variables. So that means that if we plotted them in a scatter plot, we're looking to see how closely they fit to a straight line. So if we have a look at these three scatter plots, this first one, all the data points perfectly fit in a straight line and it's sloping in the negative direction. So that there has a perfect negative correlation. This one in the middle here, there's not really any straight line any direction, so it doesn't appear to be any relationship there, so that would have no correlation. And this last one over here, again, these data points line up perfectly in a straight line, so there's a perfect positive linear relationship there. So we can use words as well. If it's not a perfect straight line, but it's pretty close to one, we can use a word like strong, so a strong correlation. If it was still sort of, you can tell which way it's going and it's approximating a line, but it's not quite a strong one, you can use the word moderate. And if it's just vaguely maybe sloping up to the right, but it's not really forming a straight line, you could use the word weak. So you've got strong, moderate, and weak. Those words aren't very accurate though, so instead we're going to introduce something called the correlation coefficient, and that's going to give us numbers to quantify that correlation instead. So like we said, the correlation coefficient tells us how strong the relationship between the two variables is. And we use the letter R to represent our correlation coefficient. So our correlation coefficient is a number between +1, which is a perfect positive linear relationship, and -1, which is a perfect negative linear relationship. So if we pull up those three images that we had just a second ago, this one over here would have a correlation coefficient of -1 because it's that perfect negative relationship. This one would have a correlation coefficient of 0 because there's no relationship. And this one would be a correlation coefficient of +1 because it's that perfect positive relationship. I want to have a look though at a few examples that aren't quite as clear. Okay, so our first example is this one here. You can see it's pretty close to forming a straight line. That's a pretty strong relationship. This one actually comes out to have a correlation coefficient of 0.9. This next one along, you can still see that it's a positive relationship. There's still somewhat sloping up to the right there, but it's not as strong as this one. We're not close to 0 though, it's still distinctly positive. So that one actually comes out to have a correlation coefficient of 0.6. And this last one, you can see that that's now sloping in the negative direction. And that one, if you calculate it, actually comes out to give a correlation coefficient of minus, because it's up to the negative, 0.8. So this one's a stronger relationship than this one is, but it's in the negative direction. We'll have a look in our next videos at how to calculate that correlation coefficient using your calculator. The last little thing I want to look at with correlation is correlation and something called causation. So causation is when we're talking about whether one of our variables has an effect on the other, so a cause and effect sort of relationship. So just because it has a high correlation doesn't mean that one variable is affecting the other. So there's a couple of different options as to what a high correlation could mean. So the first one is that one variable is affecting the other. So the age and weight of a baby up to 12 months of age is one example of that. So as they get older, their weight increases as well. So there is some sort of relationship there. So there could be causation. The second thing that could be going on if there's a high correlation is that there might be a third variable which affects both of the variables that we're looking at. So for example, the heights of children and their reading level. Their height isn't directly affecting their reading level, and their reading level is not directly affecting their height. But both of those things could be related to the child's age. So again, as they grow older, their height's increasing and their reading age is increasing as well. So there's a third variable that affects both of the ones that we're looking at. And the third one is that it could just purely be a coincidence that the two things have a high correlation. So for example, the number of registered pets in Wollongong and the number of TVs sold in Sydney. There's no reason that those two things would be related, but they could still have a high correlation if they're both increasing at the same time or at the same rate. So it's important that even if it has a high correlation, doesn't necessarily mean that one of them is directly affecting the other variable. All right, so that's a few things on correlation. Have a look at the next videos that show you how to calculate the correlation coefficient on your calculators.